In this video, we're going to go ahead and cover section 5.5, multiple angle and product to sum formulas. Still part of unit 5, analytic trigonometry. Just a heads up, this is a very long subunit, so we might go over a little bit. Let's go ahead and start with an example. We are going to be using tab number 7, which you should have already copied. So just kind of quick reminder, tab 7 is going to be your sum and difference formulas and double angle, half angle formulas. I'm also going to include a little bit more, which I'll talk about in a little bit later in the video. But tab number 8 will be used for the product to sum and sum to product formulas, which are going to be the last two examples. Okay, so you can go ahead and copy these from your slideshow. I'll show it real quickly if you'd like. All right, so let's go ahead and begin. We have example 1, solving a multiple angle equation. Okay, and we have cosine 2x plus cosine x. So what is going on here? Well, let's look at tab 7. Notice that we have here kind of like a 2 here. That is a double angle. Okay, so if we look at tab number 7, you'll find our double angle formulas right here. Sine of 2u, cosine 2u, tangent of 2u, where u is like the angle. Okay, and they're equal to the following. So sine is equal to this one or this one. So you kind of have two options. Tangent is going to be also two different options. Okay, so let's go ahead and see what we have here. We have cosine of 2x, so that means I'm going to be using the second one right here. Okay, and I think I'm going to try to use this last one just because it has a cosine already, and this has a cosine, so maybe I can try to factor somehow. Okay, so again, I'm going to use this formula and I'm going to plug in this part right here. So this is equal to this. So I'm going to use that right here. Okay, so let's go ahead and try that. We're going to replace this one right here, cosine of 2x, with that formula. So it is 2 cosine square, cosine square of x, okay, minus 1. It's a, my pen's kind of giving that a little bit here. Let me get a different one. All right, plus cosine of x equal to 0. Okay, and basically this part right here, this is what I replaced. This is what I am using the formula for, okay? And I can see that this is probably going to be something that I can factor, okay? Now you're going to ask me, how would you factor this? You have cosines and that's weird. Think of it like this. You have this is squared, right? So you have something squared, you have a constant, and you have another, whatever that something is the same as this. So let me rearrange this. Maybe that'll kind of help. 2 cosine square x plus cosine of x minus 1 is equal to 0. And now you kind of can see if this cosine was an x, it'd be like saying 2x squared plus x minus 1. Okay, so what I'm going to do is I'm going to try to factor this and see if that's an option. Okay, so for sure I'm going to have a 2 cosine x here and the cosine x here, because if I multiply this times this, that would give me 2 cosine square x. Okay, so I'm going to leave that there. For my last term to be a 1, the only thing that's going to multiply to a 1 is going to be 1 times 1. So 1 and 1. Now, what I need to figure out is which one of them is going to be negative, because for this to be negative 1, remember if you want here, let me kind of do a side note here. We're kind of thinking something like this. Okay, so this is what I'm visualizing right now, where x is kind of like your cosine x. Okay, so that's all that we're doing here. We're factoring this, but with cosines. Not a huge deal. Okay. So what times what? Let's see. If I put a minus on this part, I would have 2 times negative 1, then a positive here, it'd be positive cosine. So we'd end up with a negative here, so probably not. So let's try the negative over here, okay, and the positive right there. And just a quick check, we would do these two times each other, which would give us negative cosine x. 2 cosine times 1 would give me positive 2 cosine of x, which if we add gives us the middle term that I want. Okay, so I'm kind of doing like the inner and the outer right here. I'm just checking to see which one of these will work, that if I FOIL this, I'll get this again. Okay, so it looks like we're good to go. Now that we have factors, we're going to go ahead and set each of those factors equal to 0. So 2 cosine of x minus 1 equals 0. And the same thing over here, cosine of x plus 1 equals 0. That's what you do when you have factors, you set them equal to 0. Okay, and we're going to solve. So in the first one, we would add 1 to both sides, which gives us 2 cosine of x is equal to 1. Divide both sides by 2, which gives us cosine of x, I'm almost out of room here, is equal to 1/2. Okay, and we'll come back to this. We're not quite done. We're almost done, but we're not quite done. Same thing on this side. We're going to subtract 1 in this case to give us cosine of x is equal to -1. And actually, we can stop at that point because we're not, the cosine x is isolated. Okay, so now what I'm going to ask myself is, where is cosine of x equal to 1/2 and where is cosine of x equal to -1? So if you look at your foldable or your unit circle or whatever you're using to get those coordinates, okay, we can actually, let me get that real quick. Okay, so we're looking for where x is equal to 1/2. So I'm going to look into my little foldable here. And notice it's not this one. It's kind of this one. So we have a 1/2 right here. And this happens at pi over 6. Okay, so every pi over 6, I'm going to land here on that 1/2. Remember that this is also a factor of pi over 6 over here. Okay, so our first answer, we can say that x, the angle, remember, represents the angle, is equal to pi over 6. And we're going to go ahead and say plus 2n pi. In other words, if I go all the way around that circle again and again, I'm going to land on that same angle. So that's what that 2n pi accounts for. So every time I make one revolution, I land on pi over 6 again. Okay, so this is one of the answers to this equation. For the second one, where is cosine of x equal to -1? Well, that one should be a little bit easier, but if you need your foldable, look at the foldable. Here is -1 on pi, okay, and you'll notice it's the same on every single one. Why are we looking at the x? Because again, cosine is the x value, so it's equal to -1 at pi. So x is equal to pi. And again, plus 2 and pi, meaning if I go around and around and around n times, whatever number of times where n is an integer, remember n is an integer, we've seen this before, okay, then I'm going to land on that same spot. And that's it. That's the answer to this first one. Okay, let's go ahead and look at example number 2. We're going to just do a bunch of examples in this one. So we have find sine 2 theta, cosine 2 theta, tangent 2 theta, if cosine is equal to 5 over 13, and the theta is between 3 pi halves and 2 pi. Okay, so where is that going to be located? Well, 3 pi halves, and I'm just going to use this as reference. 3 pi halves is right here, and what is it? 2 pi and 2 pi. So we're looking at quadrant 4. So that means theta is somewhere in this quadrant. Okay, so just keep that in mind. Quadrant 4, y is negative and x is positive. So let's just remember that. So cosine of theta is equal to 5 over 13. I know from past knowledge that cosine, I'm going to go ahead and just kind of write this here, cosine of theta is equal to x over r, where it's the x value and then the radius. And in this case, we're looking at 5 over 13. So if I'm going to have to find sine and tangent, I'm going to need the y value also. So if you need to, make a little picture, something kind of small. Here's our unit circle. It's in quadrant 4, so there's my triangle. The radius is going to be 13, and my x is going to be 5. So we need to find, there's the triangle, we need to find the y. Okay, how would you do that? Well, you would just use Pythagorean theorem, which we've done several times. I'm not going to go through the whole process here. Let me get that to focus a bit. But it basically, this would be 13 squared minus 5 squared and take the square root. So if we use Pythagorean theorem, okay, we should get that y is equal to 12. Okay, and that's going to be useful for the following reasons because we need it for sine and for tangent. Okay, so with that in mind, let's go ahead and just kind of write. We know what cosine is, right? Cosine is going to be this. Let's write out sine, which is y over r. Okay, and let's remember that in quadrant 4, sine is negative. Okay, so remember this one's going to be negative. We're going to have negative 12 over 13. Okay, so there's sine of theta. We're not done. We have to find sine of 2 theta, but we need this one before we can move to that one. And then last but not least, tangent. So tangent is the same as y over x. Okay, and before we put our numbers, we have to remember that in quadrant 4, okay, tangent is going to be negative because you have y negative and x positive. So, negative and a positive is negative. So we're going to have negative 12 over 5. And we're going to need these values for the next part, okay? So let's go ahead and look at our double angle formulas, and we can see how this is going to work. So for sine, so this is kind of like the preliminary work here. For sine 2 theta, okay, that's the first one I'm going to look at. Sine 2 theta is equal to, right here, 2 sine theta cosine, or u, whatever. Remember, u is just an angle. So 2 sine u cosine u. So in our case, 2 sine theta times cosine of theta, okay? Which means I'm going to take 2 times what my sine theta is, and we can color code a little bit here if you'd like. So here's sine theta. It's going to go here. So 2 times, I guess I can keep the color, right? Times negative 12 over 13. Okay, that's the first part, times cosine of theta. And cosine of theta is up here. It's what was given. So 5 over 13. So 5, let me move this over. 5 over 13. We multiply this out just normally. And I already did this beforehand so that we wouldn't waste too much time with the video. And I got negative 120. Hopefully it's correct. Pretty sure it is. Over 169. So there is the first answer. Sine of 2 theta is equal to this, 120 over 169. Remember with fractions, when we're multiplying, it's just basically straight across. So numerators, denominators, simplify if you can. This one does not simplify, so we're done there. Okay, so that's the first one. Let's find cosine of 2 theta now. So again, we're going to look at our formulas. This subunit is heavily focused on how to use formulas. Okay, so cosine of 2 theta, here it is, double angle formulas, is cosine squared theta minus sine squared theta, or we can use 2 cosine squared theta minus 1. So let's see. Which one should we use? I think I'm going to use the 2 cosine squared theta minus 1. Let me move that away. So cosine 2 theta, I'm going to use this one right here. I couldn't remember the one that I used. I had to go back and look, but this is the one I used. So 2 cosine square theta minus 1. Okay, so that's going to give us, let's see, cosine of theta was equal to 5 over 13, one color, 5 over 13. So we're going to have 2, there's a 2 in front, times, we have to square it. So I'm going to take this 5 over 13, and I'm going to square it. Okay, that's what it tells us to do here, minus 1. Okay, this one requires a little bit more work, but it's basically the same thing. You would have 2 times, we square this, so we get 25 over 169 minus, I'm going to go ahead and do this in one step here, If you want to have same denominators, this should be a 169 also, right? So you're thinking 169 over 169. Because if it's just a 1, you just put it over 1, multiply times the same denominator, okay? And that is going to give us, after we work it out, it's going to be 50. 2 times 25 is 50. 50 minus 169, you're looking at negative 119 over 169. And that's it for that one, okay? Last but not least, we have tangent of 2 theta. I'm going to put that one right here, tangent of 2 theta. So now we're looking at the tangent one, which has a fraction, okay? But the good news is that it also has an alternate form. So let's see, we have 2 tangent theta over 1 minus tangent squared theta is equal to this. I mean, you can use whichever one you want. I want to say that what did I use for this one? I think I used the fraction because I wanted to work some fractions. So let's use the fraction. We're going to use this one. So 2 tangent theta over 1 minus tangent squared theta. So 2 tangent theta over 1 minus tangent square theta. And I've just copied the formula, guys. You do not have to memorize these. There's a bunch of formulas in this one. So I highly recommend get them all into that foldable of yours and just use them when you need them, okay? So let's see. Tangent is the last one I have here. I don't think I have a color for it. Use green. My tangent was negative 12 over 5. Okay, so that's going to look like the following. 2 times negative 12 over 5, okay, over 1 minus negative 12 over 5 squared, which is a lot of work. Yeah, but not too bad. So let's see. I might have to kind of make some space here. So this one's going to be, let me kind of box this off here. This would be negative 24 over 5, because you're just multiplying the 2 times the 12, over 1 minus, we're going to square this, so we're thinking 144 over 25. Okay, so 144 over 25. You can put it in parentheses if you want, because you still have the minus here. Okay, the negative here becomes positive because we square it, but once you subtract, it's a little bit different. So then from there, I have negative 24 over 5. I'm going to go ahead and do my keep flip change already in one step. Times this right here, I'm going to have to change that 1 to a denominator of 25. Okay, so that would be the same as saying 25 over 25. Here, if you need it, we can do it real quick. 25 over 25 minus 144 over 25. Okay, which would give us negative 119, I believe. I want to say yes. Yes, I believe that's what I got. Negative 119. So we're thinking time. This would be negative 119 over 25. Lots of side work for this one. And we're going to flip this fraction because, well, we're doing the keep flip change over here. So we're thinking 25 over negative 119. Weird, crazy weird. That's going to give us, we can simplify this by 5. So we have a 5 left there because we divided out. Multiply this out, that's going to give us 5 times negative 24. Let's see, 5 times 4 is 20, carry the 2, 5 times 2 is 10, 2. So we're thinking negative 120 over negative 119. The two negatives make a positive, so we have 120 over 119. And that is our answer for tangent. Tangent's complicated, but if you think about it, this all right here, this is not trig. This is just algebra and not even algebra, it's arithmetic with fractions. Okay, so that is it for that one. Okay, let's go ahead and move on to the next problem. There's quite a bit more. Like I said, we might go over on this one. This might be the exception for my 30-minute rule here. Okay, Let's look at some information here. We have a double angle formulas are not restricted to angles 2 theta and theta. So for instance, if you had like sine of 4 theta, cosine 6 theta, this would be the same as doubling it basically. So 2 sine 2 theta, cosine 2 theta. And you want to kind of compare it so you can kind of see what I'm talking about. Sine of 4 theta, we're thinking this one, right? Sine of 2 theta, it's normally 2 sine u, cosine u. But if you double it, well, you have to double that one too. So you put a 2 here and a 2 there. And this applies to kind of some other ones as well. Same thing with this one, okay? So let's go ahead and try this example now. Okay, what I'm going to do with this one is I'm going to rewrite it in a way where it's not so difficult. So we're going to rewrite cosine of, let me go ahead and move this down a little bit. We're going to rewrite cosine 3x in terms of 1 cosine. Okay, so let's try it this way. I'm going to say that cosine of 3x is equal to cosine of 2x plus 1x, because that's true. 2 plus 1 equals 3. Okay, and if I do that, I know that this one right here can be written as, let me see, my sum formulas that I had from before. Yeah. So if you don't remember those are at the top of tab 7 still. We had our sum and difference formulas up here. We had cosine of something plus something. So I'm going to use this one right here. Cosine of u plus v equals cosine, cosine, 2 of them, minus sine, sine, 2 of them. So I'm going to use that for this right here. So this is equal to, I should have done that there, cosine of 2x times, so that's like our u, okay, cosine of x, that's like our v, okay, and then we are supposed to subtract after that. And again, I'm just following the formula, okay, so minus sine of 2x times sine of x. Okay, so now what can I do with that? Well, I want to make this all in terms of cosine. So you see how we have this double angle right here, 2x. Now I can go ahead and look at my double angle formulas and say, what is this equal to in terms of cosine? So I think I'm going to use this one right here because that one has cosines. We don't want sines. We want to get rid of the cosines. So let's go ahead and use this one right here. And that is going to give us, so I'm going to replace, get my tape some color here just to kind of show you. I'm going to replace this part right here with cosine, 2 cosine square of x minus 1. And again, this is directly from the folder because I do not have all of these memorized. I do have to use it. I'm going to have some memorized, but I want to show you that all you got to do is look for it. Okay, so again, this one is coming from right here. Cosine 2 of x or u or whatever is equal to this guy right here. That's what I'm showing you right here. Okay, so all that is the part in pink times cosine of x. I still have that cosine right there. Okay, minus, now we have sine. So sine of 2x is also one of the double angles. We have 2 sine x cosine x. So let's go ahead and replace this one now with this one. So 2 sine of x times cosine of x. And we're replacing this part with this part right here. So I still have that sine x at the end. I still have this one right here. So times sine of x. Okay. Now what can we do? Well, I can probably distribute this part because this right here is being multiplied, right? So I'm going to go ahead and do that real quickly. That's going to give us, let's see, 2 cosine x times 2 cosine square x is going to be 2 cosine to the third power, right? Minus cosine of x. So I just distribute it, that's all, like that. Minus, what happens over here? Well, I see that I have sine x 2 times. So let's go ahead and make that into sine square x, okay? And bring down the cosine. Why am I doing that? Well, because I know from my other identities from before, okay, and I'm going to show you where this one is. I know from my Pythagorean identities that sine square of theta can be written in terms of cosine, and I rewrote it over here. It's equal to 1 minus cosine square theta. So I'm going to put that in there. So now we're going to have 2 cosine cubed x minus cosine of x minus 2 times, so now I'm going to replace sine square x with 1 minus cosine squared x. And I still have this cosine out here, so times cosine of x. And now we have a bunch of cosines, which is what we kind of wanted, right? So let's go ahead and multiply everything out. I'm going to multiply this part right here, which would give me, let's see, we distribute, so we would get cosine of x. So 1 times cosine of x is cosine of x. Cosine of x times negative cosine square x is negative cosine to the third power. And all that is going to be times 2, right? So I'm just going to bring everything down. So that's a minus. I'm just bringing everything down. That's all I'm doing. Okay. And from there, I'm going to distribute my 2. So minus 2 cosine of x plus 2, because negative times a negative is a positive, right? So plus 2 cosine of to the power of 3x, and then bring everything down. Okay, and it looks like we can get rid of some stuff here, maybe, possibly. Oh, no, actually, no, we can't. But we can combine some stuff, right? We can say, we can see that these two, so 2 cosine x to the third power, 2 cosine x to the third power, that's going to give us 4. So we have 4 cosine of x to the third power. And then I can also combine these two, negative cosine x, negative 2 cosine x, which gives me negative 3 cosine x. And I believe that that is it, because we wanted this to be in terms of cosine of x. That was the whole point of the problem. So we wanted to get rid of those double angles, right? And we did. We have cosine of x. This one's cubed, but it's still cosine of x. So we are finished with this problem. Okay, and I think this is the last one I'm actually going to do. The rest of them are already done for us. I hope we're not over too long right now. We'll see. I guess we'll see how long this video ends up being. We have some formulas that are not going to be in your foldable, and I didn't put these in because we don't use them too often. So go ahead and write them down real quick. These are the power reducing formulas, and I'm going to show you how they come into play. Let me move that over a little bit on the next example. Okay, so sine squared theta, cosine squared theta, tangent squared theta. In this case, we're using u for theta, but it still represents the angle. Okay, let's look at this monster of a problem. We have example number 4, which is rewrite tangent of x to the fourth power in terms of first powers of the cosines of multiple angles. So that sounds super complicated, but it's actually not that bad. It's a little bit bad, but not that bad. So I'm going to show you the solution to this one because it is a very lengthy problem. This is tangent of x to the fourth power, which we can break down into tangent square x to the second power because, well, you can 2 times 2 is going to give us that 4. Okay, this means that I'm going to square whatever tangent square x is equal to. Okay, according to what I had over here on the other page, so on the page before that I just showed you, tangent square of x is equal to all of this. Okay, so I'm just replacing it. This is equal to that. And then I'm going to square it. Okay, when you square something, that means you have 2 of them. So I wrote it 2 times. Okay, on this step, it's just FOIL, so do not freak out. Basically, what I did is I said, I'm going to take this parentheses and multiply it times the top, and then the bottom parentheses and multiply it times the bottom. And we're just using FOIL to get to this part here, okay? So 1 times 1 is 1. Let me cover the next part because I don't want to throw you off too much there. Let's do this. Okay, there we go. So 1 times 1 is 1. Negative cosine 2x times 1 is going to give me negative 1 cosine 2x. You're going to have another 1 because you have 1 times the same thing. So that's why we have two of them. 1 minus 2 cosine of 2x. And then when you multiply the last term, so cosine 2x times cosine 2x, we get cosine squared 2x, and it's positive because you have a negative times a negative, okay? Same thing with the bottom, except instead of, since they're both pluses, we have all pluses. So this is what we end up after we FOIL. Then I broke it down in pieces after this. So I went ahead and replaced this one now. So both of these are replaced with the cosine square theta power formula. So I'm going to jump over here again. There it is. This is the formula. It has a fraction. Okay, so this is replacing this now. So let's see what that looks like. We have this next step right here. So this part and this part changed. Everything else is the same. Okay, so I just replaced that with that. And now this is where all the fraction work comes into play. So you're going to notice a lot of fraction stuff with these problems. Here we go. We need to simplify the top and the bottom. So what I did is I found common denominators. So that 1 became 2 over 2. I multiplied 2 over 2 times this one also because it's the same as 1. Basically, I did 2 over 2 to the places that did not have a denominator of 2. Okay, so this is just showing you where that's coming from. And then we simplified it. So all those 2's that we were just looking at, so we can get it all in the same shot here. Oh, probably not. Okay, well, all the 2's that were here, so the 2 here, 2 there, we went ahead and did all the top parts. So now we have the numerator all over 2. Same thing on the bottom, the numerator all over 2. And you'll notice that we have a huge fraction within a fraction. So like this line right here, this is the main, like I guess you could say fraction. This is the one we had originally had here. So there and there. Okay. So you'll notice that everything, we have like two fractions basically within one. And then at this point, I went ahead and just did all the distribution. So I said, I'm going to go ahead and distribute this and distribute this one, which 2 times 2 will give us 4. Okay, and that's the only difference from here to here. We have a 4 there and we have a 4 there. Okay, no big deal. Almost done with this one. So here I did my keep flip change. So KFC. My keep flip change says that I'm going to take the first fraction, leave it, change this to a multiplication, so that division is now a multiplication, okay? And flip the second fraction. You will notice that the 2's are going to be equal to 1. So I am left with all of this on top, all of this on bottom. I just kind of rearranged it a little bit, and that is it. Very lengthy problem. Mostly fraction work, okay? Nothing too crazy. That's it for that one. Let's go ahead and look at, I think we have a couple more. Let me see. It might just be one more. Oh, we have two more. We might do the last one in class because I know this video is getting kind of long. We'll see. The last one is actually really quick. So we have example number 5, and it's also done for us because, again, the time, this one does have a half angle formula. So you're going to look at your half angle formulas. Yeah, half angle formulas are still on tab 7, and they are in this little box thing that I kind of had to fit here. And basically it's if you have an angle, and you know that half of it, or you have an angle, you know double it is what you're looking for. Hope I said that right. You can use these formulas. Okay, so for example, we have find the value of cosine of 105. So if I double cosine, I get 210. And 210 divided by 2 is 105. So I can use this formula. Let's say I can use this formula. Cosine of u over 2 is equal to plus or minus square root of 1 plus cosine u over 2 to try to figure this out, where u is going to be my 210. Okay, So why am I using 210? Why is that one important? Well, because if you think about it in our unit circle, and again, this part you do not have to do, but if you think of our unit circle, okay, 210 is over here somewhere. And it happens to be 30 degrees away from my the horizontal line, right? This is 180. So it's one of the important points that we have coordinates for. And if you look at our little foldables over here, okay, this one in particular, where 30 degrees is, if we go all the way around 30, 60, 90, 120, 150, 180, 210, we have the coordinates for 210. So that's why 210 is it's a preferable angle. Any angle that you have on any of these circles, we have coordinates for. That's why we like to use them. Okay, so I'm going to use the coordinates for this spot right here. How does that help us? Well, I can plug it in. 210 divided by 2 is 105. So these are equal. Okay, so therefore I can use the formula. 1 plus cosine of 210 over 2. Again, this is just a formula. If I move on to the next step, there's a few steps here. We're going to go one at a time. 210, since we're looking at cosine, okay, cosine, remember 210 is right here. I'm going to take the value of x, which is negative square root of 3 over 2. This one right here. So that's all I did right here. I just replaced it. 1 plus negative square root of 3 over 2 over 2. At this point, the rest of this is just arithmetic. So it's no longer trigonometry, okay? So if you have trouble with this part, please ask me questions. Come in for tutoring. Let me know so I can help you. I'm going to try to get a common denominator. So I change the 1 to a 2 over 2. Combine those two, which gives us 2 minus square root of 3 over 2 all over 2, okay? And then we're going to do our keep flip change, just like we did the other one. So from here to here, we did our KFC here. So we keep we kept this one, and then we flipped the second one. Remember, this is like 2 over 1. And we changed the division, so this division to multiplication. Okay. You'll notice that 2's do not give me a 1. They actually end up getting multiplied, which gives us a 4. But luckily for us, since we're taking the square root of all this, it's the same as taking the square root of the top and the bottom. Okay. That should be all the way there. So the square root of 4 is equal to 2. And that means that I can go ahead and just say the top is square root of 2 minus square root of 3. I can't do anything to that one. That one stays the same. But I have that 2 by itself now with no root anymore. So make sure that the root is only on the top. Okay. And finally, I went ahead and said we're going to use the negative 1 because our original angle, 105 degrees, is in quadrant 2. And in quadrant 2, cosine, which is the x value, is negative. Okay, so that's why we chose the negative 1 for this one. Last but not least, and this one I think I am going to do super quickly. It does not take that long to do. So tab number 8, I believe, is where I added these last formulas. We're going to be doing product to sum and then sum to product. So tab number 8 is the one I was talking about earlier. I'll show it very quickly if you want to copy it now. But basically, these are our product to sum formulas. Okay, and then these ones are our sum to product formulas. So going the other way. For this example, we're going to be using the first one, the product to sum. Okay, so let's see what they want. They want rewrite the product sine of 5x cosine x as a sum or difference. So I'm looking for sine cosine. So let's see which one has sine cosine. This one, right? Sine cosine is equal to 1/2 all that. So whatever I write here is based off of this formula here, and I can try to fit it on all. Well, I guess I can try to fit it. Let's see if we can get it all in one shot here. So our 5x is the u, and this is the v. Okay, that's what we're going to be using. So let's see. We have equal to 1/2 sine, looking at this one, of 5x, okay, put that in parentheses, plus, what's the other one? 3? I already forgot. Yeah, 3x, okay, plus, my pen's getting tired here, sine I'm out of ink. Sine of 5x minus 3x, okay? And then we just simplify, so this is going to be the same as sine of 5x plus 3x is 8x over 2, or times a half, okay? Because this whole thing is multiplied by a half, so you kind of have to distribute it at some point. Sine of 5x minus 3x is 2x, also over 2, and guess what? We are done. See, that wasn't so bad. That's it, guys. There's one more example, but I think I'm going to do it in class, and it does have to do with the other half of the sum to product. So do make sure that you do have this written down. I'll go ahead and attach it to your slideshow so you do have that for reference. If you have any questions, as always, let me know.